Hello pre-calculus students. In this video, I'm going to explain inverse trig function. But before we jump onto the trig functions, let's take a look at a quick review. What is inverse actually? So let's say f has a x and y, then f inverse, we write it like this, and the coordinates are switched, which is y becomes x, x becomes y. Another important fact you have already learned, but you are supposed to know that if f of g of x is equal to g of f of x and you get the x back, then we can say f and g are inverse of each other. So we are going to use this concept which we learned in the previous unit in this topic, inverse trig function. So let's start with a sine. We have three trig functions: sine, cosine, and tangent. In fact, we have 6 trig functions, but we are not going to do the other three. So in this topic, we are going to do sine inverse, cosine inverse, and tangent. So only of these 3 functions. You are not supposed to know, secant theta, cosecant theta, and cotangent theta inverses are not in the curriculum, so only need to know 3. So that's a good news. Okay, so let's start with a sine x. Now to begin with, I gave you radi graph, what the sine graph looks like. So let's talk about the coordinates. This is a 0, 0. So we are going to explore how the graph looks like. So if this is a 0, 0, then sine inverse will also have 0, 0. Now let's take a look at this point is a 1 and which is pi over 2. You are supposed to know the trig function. Sine, this is 0, this is pi. So pi over 2 is a 1. So for inverse sine, 1 become pi over 2. Then you got the idea that this is a pi is a 0, then it becomes 0 and pi and onwards, right? But we got some idea how this would look like. So all the x values and y, x becomes y, y becomes x. So think about again, I'm going to use the range is always negative 1 to 1. So that becomes domain negative 1 to 1, which means my x value is negative 1 and 1. Graph is a 0, 0. Then let's choose the y coordinate. This is a pi, this is 2 pi. Remember, x becomes y, y becomes x. So this is negative pi, this is negative 2 pi. So how does this graph look like is if we switch x and y, so my graph will be like this. And you can see this is pi over 2 is a 1, you can say. And my graph would look like something like this. So these are all the values I have transformed. The question is this a function? Clearly, it does not pass the vertical line test. So it's not a function. To make a function, we have to restrict this graph. We have to restrict the domain of sine so that it is 1 to 1. To make a 1 to 1, which means you have to choose a portion of the graph. For example, I can't choose this because it's not 1 to 1. It won't pass the vertical line test. So which is the good portion we can use? Can I use this piece? Can I use this piece? Can I use that one? Which piece of the graph we have to choose in other mathematical word is restrict the domain so that it pass 1 to 1 test. So now I have to look for the 2 consecutive quadrant, which means this is the some positive, some negative, and this is the restricted domain of a sine so that we can make sine inverse function. So this is the graph of sine inverse x. We are going to summarize also. So let's take a look at the domain of sine is all real number, but we need to restrict the domain. to negative pi over 2 to positive pi over 2. Restrict the domain negative pi over 2 to positive pi over 2, which means the range is this. Know that sine graph goes forever up both sides, but sine inverse does not go forever up and down. It is restricted to this piece. So summarizing is, I can explain here in this piece here, you can say again one more time, we are going to restrict this piece of the graph so that it is a function. Okay, so now let's explore cosine graph. Okay, so I'm just explaining the ready information here. This is a cosine graph, starts at 1, -1, and this is a 1 and -1, x becomes y becomes x. We can clearly transform those points without making a table. So this is a 2 pi, pi, -pi, and you can say -2 pi. So if I sketch the graph, 0, 1 becomes 1, 1, 0. Pi is -1, so pi is -1. Now clearly it's not a one-to-one, so we are going to restrict the domain of cosine function as 0 to pi. Restrict the domain. We are going to restrict the domain as 0 to pi. This is a normal, no, this is a normal domain. But restricted domains, what is a restricted means? It has to pass 1 to 1. It has to be a function. So to make it 1 to 1, we have to select a piece of the graph. Again, in not mathematical language is select the piece of the graph which is purely increasing or purely decreasing. If I choose increasing and decreasing, clearly it's not going to be a function. So I'm choosing purely decreasing so that it is 1 to 1. And this is the graph of cosine inverse. So let's take a look at the properties. And if I restrict the 0 to pi, which means on the unit circle, I'm cutting off the half of the circle from 0 to pi. I'm selecting top half of the circle. For sine inverse, I'm selecting right half of the circle, which means 0 to pi over 2 and 0 to negative pi over 2. 0 to pi over 2, 0 to negative pi over 2. So one more time, take a look at this. We are looking at the restricted domain so that the function becomes 1 to 1. Okay, so curious, how does the tangent graph look like? So I'm giving you ready tangent graph, which we already learned in a previous section. Tangent graph has asymptote at every pi over 2. Tangent graph has asymptote at every pi over 2. This is pi over 2. You can see period is a pi. This is 0, 0. Tangent graph period is a pi. Asymptote at pi over 2. Okay, so we have to see how the inverse tangent look like. So we know that x becomes y becomes x. So vertical asymptote become horizontal asymptote. It's a very interesting function. So vertical asymptote become horizontal asymptote. And it passes through 0, 0. Now, clearly, how do we restrict the domain? If I cannot take all of them. If I take all of them, then I have so many pieces of graph and clearly it won't pass vertical line test. So I cannot take all the pieces and it is very obvious in this case which piece you would choose. The piece I'm choosing is the right one in the middle. This is the piece I'm choosing because it is a positive, some negative. We don't want all positive, all negative. We don't want the pieces. So what the tangent inverse graph look like is, I'm going to go one more time here. Tangent inverse graph is very important because we are using it so much into calculus as well. Bear with my graphing. My graph is not very coming out very clean here, but let me bring my notes here which I have a better looking graph. Okay, so I'm going to explain here how does the tangent graph look like, and I will explain in this picture. Okay, so tangent inverse has a two horizontal asymptote. This is a horizontal asymptote, that's a horizontal asymptote. So two vertical asymptote become two horizontal asymptote. Another important fact about tangent inverse is you are expected to know the end behavior, because tangent graph goes forever up and down, which means it goes forever right and left. Now, why didn't we worry about end behavior of the sine inverse, cosine inverse? But remember, sine inverse, cosine inverse are the two pieces only. They don't go forever anywhere. They are only bound by certain numbers, whereas tangent is the only one which goes forever to the left, forever to the right. Now, if I look at the domain and range, if it is restricted to these two, this will be parentheses. Notice that they are parentheses. Why? Notice that this is parentheses, not bracket. Why they are parentheses, not bracket? Because of the horizontal asymptote. Horizontal asymptote, that means it goes forever but does not touch. Okay, so before we get full-fledged into inverse trig function, it's worth reviewing trig function that input-output. So let's think about if I say sine of theta, which means this is an angle. What will be the answer? Answer will be a ratio. Now what is sine inverse? Sine inverse is working backward. Which, for example, let's say sine pi over 6. I'm giving another example much easier to understand. We know from the unit circle, sine pi over 6 is a small angle, opposite side is a small one, which is 1/2. So what this means is if I take this sine other side, it will become sine inverse. Then what's the angle? Is pi over 6. So know that answer of sine inverse is always answer is a angle. Answer is a angle. So let's take a quick one more time. If I say sine inverse x, what you are expecting? Answer is a angle. It could be in terms of pi or it is just a number. Either way you say it's always angle in radian. We never use degree. Angle in radian. Okay, so let's take a look at a quick summary before we jump into the problems. So here is a inverse sine is also called arc sine. You are supposed to know that. This is a quick summary page. How does this graph look like? It stops here. It does not go forever. Domain is -1 to 1. Range is -pi to pi. Now, why we have two different names? Because angles are the same as arc length on the unit circle. If you recall the for definition of a radian, radian is a ratio of arc length divided by radius. So angles are the same as arc length because radius is always 1. So that's why the word arc come from, and every inverse function, arc sine is same as sine inverse. Arc cosine is called cosine inverse. So know that sine inverse of x is also said as arc sine of x. Answer is always angle. Answer is always angle. So this page is a summary and notation. You have to know the correct notation. Now another one, cosine inverse is also called arc cos. So remember the arc means angle. Arc means angle and angle is always radian. So this is -pi to -1 to 1 and the range is 0 to pi. It does not go forever. It stops there. Now you will not be asked to sketch the graph of sine inverse, cosine inverse, but you must know this graph. You must know this graph. You must know this graph. It will be used. You will ask to sketch and properties. Everything about tangent inverse graph is important because we use them in calculus as well. Okay, so as usual, arctan, tangent inverse, same. It goes forever in each direction. One more time, there are two horizontal asymptote. Must know the end behavior of this. End behavior means limit goes x goes to infinity, tangent inverse level off at pi over 2. Now notice that this is very similar to cube root. This is very similar to cube root, but the cube root goes slowly forever. This graph levels off at pi over 2. Okay, so before we jump into again all the problems, let's take a look at this summary. I would like you to pause the video here and try to fill in this table. Try to fill in this table. This table you are supposed to memorize. You must know every single detail of this table. So first of all, we are reviewing original 3 and the inverse of those 3. So this is the sine x, normal 0 to 2 pi, period is 2 pi, negative 1 to 1, and let me add that, period is 2 pi. Domain is all real, range negative 1 to 1. So how does the sine inverse look like? So remember, sine inverse, you have to restrict this piece of domain. Then that is the graph. Now x becomes y becomes x. So that's why concavity changes, negative 1 to 1. Okay, so let's talk about the circle. This circle, you can't just say negative pi to 2 pi, negative pi over 2 to pi over 2. You have to start from 0, 0 to pi over 2 and 0 to negative pi over 2. You cannot jump from here to here because you have to stop at 0. So range is fourth quadrant, we always go negative angle. Fourth quadrant, we go negative angle. Cosine, let's quick review. Cosine 0 to 2 pi, period is 2 pi. We restrict to this piece and that will give you restricted domain. Domain becomes range, range becomes domain, know that. And on the unit circle, this is a 0 and we go normal. So cosine inverse is a nice, it's easy to remember because there is no negative number involved, 0 to pi. Because first quadrant cosine is positive, second quadrant cosine is negative. So we are taking top half of the circle. For sine inverse, we are taking right side of the circle. Let's talk about tangent inverse. Tangent inverse, one more time. Tangent graph passes through 0, 0. It's an increasing function and domain is all real, but x cannot be. First asymptote at pi over 2. This is a review for, and this is a really good review for assessment as well. K is any integer. Of course, I forgot to write that. K is any integer. The range is all real, which means domain becomes all real. And notice the parentheses. Notice the parentheses because of the horizontal asymptote. Parentheses because of the horizontal asymptote. Again, tangent, fourth quadrant, you need to use negative angle. For example, this is not a 7 pi over 6. No, sorry, this is not 11 pi over 6. This is negative pi over 6. This is negative pi over 4. Be careful. You have to look at the circle different way. So how about we try some problems here? Okay. So let me clean up. I don't want you to see my answer. I want you to know how to do it. So cosine inverse negative half. So let's say this is equal to theta. I'm showing you the easy way to do it. So we can say cosine theta is negative half. On a unit circle, cosine is negative here and here. But cosine inverse have this top half of the circle, which means what's that angle? Now, is it going to be a small, medium, large? What's the angle? So you can see cosine is a half. That means it's a large angle. Large angle is 2 pi over 3. What that means is cosine inverse negative half is equal to 2 pi over 3. Okay, so let's take a look at another one. Sine theta, sine inverse is a 1. So what's the angle so that sine is 1? You can say it backward. What's the angle so that sine is a 1? Sine is a 1 is up here north. What that means is this angle is pi over 2. alternate approach, you can say sine theta is pi 1. So what's the angle? Pi over 2, which is same. Okay, arc sine. No, that is same as sine inverse negative root 2 over 2. So let's say this is equal to theta. Approaches, I'm showing you so many different ways to do it. Sine theta is negative here and here. Sine theta has this half of the circle, so I can't use that. What will be this point? I cannot use forward angle. Remember, sine is backward. So what's that angle now? Is it a medium, small, or large? What's that angle? You can see root 2 over 2 is a medium angle. Medium angle means negative pi over 4. So pause the video for a few minutes on this and try this part of this problem, and we can go over all the answer. I would highly recommend pause the video and do all these problems one more time. Okay, so let's check all the answers. Okay, so arc cos negative 1, which means cosine theta is negative 1. What's the angle so that cosine is negative 1? Cosine is negative 1 here, so the answer is pi. Sine root 3 over 2, root 3 over 2, sine, that means some small, medium, large. This is a large angle, which is pi over 3. You can say that what that means is, again, sine theta is root 3 over 2. What's the angle theta? Arc sine 0, which means sine theta is a 0. What's the angle so that sine is 0? Sine theta means y is 0, y is 0 on here and here, but the sine inverse is this side, so answer is 0. Cosine theta is 1/2, which means x is a 1/2. This is a x is a 1/2. That means small angle, which is pi over 3. Tangent inverse, really cool problem. Tangent is negative here and here. Tangent inverse is this side. You must go backward. This is very, very popular problem. Tangent inverse negative 1. You must know one of the answer choice. If it is a multiple choice, one of the answer choice would be 7 pi over 4. But know that fourth quadrant, you must go backward. Tangent theta is a 0. Let's review. This is for slope is a 0. Slope is a 0 on east and west. But tangent inverse is this side. You cannot go to the west. Answer is a 0. Same thing. You can't go to the west. Answer is a 0. So this is you can pause the video again and let's try all these answers without calculator. It's just the format is different. So basically it's asking for what is sine inverse half? What is sine inverse negative half? I'm just rewriting. What is sine inverse negative root 3 over 2? What is sine inverse 1? These are all easy answers. This is a very interesting question. Sine inverse pi. Now remember, the answer is always the angle. But the domain is sine inverse is negative 1 and 1. And what's the number pi? Pi is 314. 314 is clearly not in this. So this does not exist. Does not exist. I'm writing the answer quick. This is pi over 6. This is negative pi over 6. This is negative pi over 3. Remember, fourth quadrant, everybody goes negative. And this is pi over 2. So practice with problems on the other side. This is just a review of the unit circle, how you should be looking at the circle. And the next video, we will be talking about composition.